Hello, welcome back to statistics. We're talking about analysis of variance. We're going to talk about the basics here. So this lesson and the next several lessons will be going through the components of the calculations one little piece at a time. So the first piece is called the grand mean. It's the easiest piece to understand. It's very, very simple. But before we get to that, let's look at this problem. What we're going to do is end up solving this problem by hand. I know in the previous section we talked about school districts and testing. That was great to keep in your brain just because everybody has some experience with grades. But this is a real problem. So below are the ages that females get married in New York, Texas, and Oregon. So you see we have New York here, Texas, and Oregon, and we have some numbers written down here. So these are the ages that girls get married. So in New York, we have one person that got married at 18 years old, and one at 19 years old, and so on. So everybody you ask, there's 10 people that we sampled in New York, 10 people we sampled in Texas, and 10 people that we sampled in Oregon. So this is another example. The population that we're studying is the entire New York female population, the age that they get married. The population here is all the females in Texas. The population here is all the females in Oregon, but we can't sample everybody. What we want to do, we just can't do that because there's not enough money or time. What we want to do is perform an analysis of variance test to see if the average age of marriage in these three states are equal. So again, analysis of variance, 3 or more populations, in this case 3, but we could have Louisiana and Kentucky and Florida if we wanted to. We could continue doing testing and do them all at once. But we cannot know the population average. We can't sample all girls in Texas, all females, and figure that out. It's just too costly. So we sample 10 from each of these guys, and we want to figure out from that information at a 0.1 level of significance, which means 90% level of confidence if this data indicates that the average age of marriage in these three states are the same or not. Now I have the numbers here because the equations I'm going to write down are going to have subscripts 1, 2, 3. So when you see a number 1, it means New York, number 2 means Texas, number 3 means Oregon. You should label your data that way as well. All right, so first thing we need to do is write down the null and alternate hypothesis. And I already told you that it's always the same for these problems, but let's write it down anyway. The null hypothesis is that the average age that females get married in New York, see, mu number 1, this is population 1, is equal to the average age of the females in population 2, which is equal to the average age in population 3. That's the null. That's the currently accepted hypothesis that we think is true. What would then be the alternate hypothesis? Well, it just means that at least one of these means is different. And I want to remind you, we did talk about it in the last section, I want to remind you though that even at the end of this test, I'm really not going to know which of these means is different, if any of them are different. I'm just going to know that one of them is different. You have to do different testing beyond the scope of Anova to figure out which one of them is different. All right, so the first thing we're going to talk about is the concept of the grand mean. So let me write that down. Grand mean. Because here's the deal. I've got sample data from population 1, sample data from population 2, sample data from population 3. So what I'm going to end up doing is I'm going to average this data and I'm going to get a number. That's going to be the sample mean from population 1. Then I'll average all of this and get a sample mean from population 2. Then I'll average all of that and I'll get a sample mean from population 3. So I'll be comparing those 3 sample means together. I'll be comparing them. But how am I really going to know if any of them are different? I mean, what were you doing in the previous section where we're looking at the test scores? I mean, I graphed it so you could visually see it, but what were you really doing? You were looking at those 3 scores and comparing them to each other, but really what you were doing is comparing them to a common baseline. The common baseline that you're going to end up using to compare each of these averages to is what we call the grand mean. Basically, you have all of this data here, so if you take the mean of each of these sample means, let's say you get a sample mean from this data, sample mean from this data, sample mean from this data, so you have a mean from New York, a mean from Texas, and a mean from Oregon. If you average all 3 of those means together, you get what we call the grand mean. So I'm going to write it down. It is the mean of the sample means. Right? So I'm going to say this a few different ways. It's a really simple concept, but the reason I'm saying it this way is because your book is going to describe to you. It's going to say the grand mean is the mean of the sample means. And a lot of people look at that and say, what does that mean? Well, I'm telling you what it means.